Hello friends, welcome to another model. This model is on hypothesis testing. A hypothesis is considered as the principal instrument in research. Its main function is to suggest new experiments and observations. In fact, many experiments are carried out with the deliberate object of testing hypotheses. Decision makers often face situations wherein they are interested in testing hypotheses based on available information and then take decisions based on such testing. In social science, where direct knowledge of population parameter is rare, hypothesis testing is the often used strategy for deciding whether a sample data offer such support for a hypothesis that generalization can be made. Thus, hypothesis testing enables us to make probability statements about population parameters. The hypothesis may not be proved absolutely, but in practice, it is accepted if it has withstood a critical testing. Before we explain how hypotheses are tested through different tests meant for the purpose, it will be appropriate to explain clearly the meaning of a hypothesis and the related concepts for better understanding of the hypothesis testing technique. The objectives of this module are to understand the meaning and characteristics of a hypothesis, to be able to comprehend the basic concepts in stating a hypothesis, to be able to systematically test a hypothesis. Meaning of hypothesis. Ordinarily, when one talks about hypothesis, one simply means a mere assumption or some supposition to be proved or disproved. But for a researcher, hypothesis is a formal question that he intends to resolve. Thus, a hypothesis may be defined as a proposition or a set of propositions set forth as an explanation for the occurrence of some specified group of phenomena, either asserted merely as a provisional conjecture to guide some investigation or accepted as highly probable in the light of established facts. Quite often, a research hypothesis is a predictive statement capable of being tested by scientific methods that relates an independent variable to some dependent variable. For example, consider statements like the following ones. Students who receive counseling will show a greater increase in creativity than students not receiving counseling, or the automobile A is performing as well as the automobile B. These are hypotheses capable of being objectively verified and tested. Thus, we may conclude that a hypothesis states what we are looking for, and it is a proposition that can be put to test to determine its validity. Now, let us look at the characteristics of hypothesis. Hypothesis must possess the following characteristics. Hypothesis should be clear and precise. If the hypothesis were not clear and precise, the inference drawn on its basis would not be reliable. Hypothesis should be capable of being tested. The researcher can do a preliminary in order to state a testable hypothesis. A hypothesis is testable if other deductions can be made from it, which in turn can be confirmed or disproved by observation. Hypothesis should state relationship between variables if it happens to be a relational hypothesis. Hypothesis should be limited in scope and must be specific. A researcher must remember that narrower hypotheses are generally more testable. Hypothesis should be stated as far as possible in the most simple terms. This would help all those concerned to understand it easily. But one must remember, simplicity of hypothesis has nothing to do with its significance. Hypothesis should be consistent with most known facts. That is, it must be consistent with a substantial body of established facts. In other words, a judge should accept it as being the most likely. Hypothesis should be amenable to testing within a reasonable time. One should not use even an excellent hypothesis if the same cannot be tested in reasonable time, for one cannot spend a lifetime collecting data to test it. Hypothesis must explain the facts that gave rise to it, the need for explanation. This means that by using the hypothesis plus other known and accepted generalizations, one should be able to deduce the original problem condition. Thus, hypothesis must actually explain what it claims to explain. It should have empirical reference. Now let us look at the basic concept concerning testing of hypothesis. Basic concept in the context of testing of hypothesis need to be explained. Null hypothesis and alternative hypothesis. In the context of statistical analysis, we often talk about null hypothesis and alternative hypothesis. If we are to compare method A with method B about its superiority, and if we proceed on the assumption that both methods are equally good, then the assumption is termed as null hypothesis. As against this, we may think that method A is superior or method B is inferior. We are then stating what is termed as alternative hypothesis. The null hypothesis is generally symbolized as HO and the alternative hypothesis as H alpha. A significance test examines whether the null hypothesis provides a plausible explanation of the data. The null hypothesis itself does not involve the data. It is a statement about a parameter, a numerical characteristic of the population. These population values might be proportions or means or differences between mean or proportions of correlation or odds ratio or any other numerical summary of the population. The alternative hypothesis is typically the research hypothesis of interest. Here are some examples. Hypothesis with one sample of one measurable variable. A generic brand of the antihistamine diphenylhydramine markets a capsule with a 50 mg dose. The manufacturer is worried that the machine that fills the capsule has come out of calibration and is no longer creating capsules with the appropriate dosage. The research question would be, does the data suggest that the population mean dosage of this brand is different from 50 mg? The response variable would be dosage of active ingredients found by a chemical assay. The null hypothesis and alternative hypothesis can be stated as null hypothesis. On the average, the dosage sold under this brand is 50 mg. Alternative hypothesis. On the average, the dosage sold under this brand is not 50 mg. This is a two-sided alternative hypothesis. Example 2. Hypothesis with two samples of one measurement variable. Obesity is a major health problem today. Research is starting to show that people may be able to lose more weight on a low carbohydrate diet than on a low fat diet. The research question would be, does the data suggest that on the average people are able to lose more weight on a low carbohydrate diet than on a low fat diet? The response variable would be weight loss. Explanatory variable would be type of diet. The null hypothesis and alternative hypothesis can be stated as null hypothesis. There is no difference in the mean amount of weight loss when comparing a low carbohydrate diet with a low fat diet. Alternative hypothesis, the mean weight loss should be greater for those on a low carbohydrate diet when compared with those on a low fat diet. This is a one-sided alternative hypothesis. Now we shall see the steps in the process of statistical hypothesis testing. There are 7 steps and we will cover them one by one. Step 1. State the null hypothesis. Hypothesis testing begins with an assumption called a hypothesis that we make about a population parameter. A hypothesis is a supposition made as a basis for reasoning The conventional approach to hypothesis testing is not to construct a single hypothesis about the population parameter, but rather to set up two different hypotheses, so that of one hypothesis is accepted, the other is rejected, and vice versa. Null hypothesis. A hypothesis of no difference is called null hypothesis and is usually denoted by H0. Null hypothesis is the hypothesis which is tested for possible rejection under the assumption that it is true. It's a very useful tool in test of significance. For example, if we want to find out whether the special classes for students after school hours has benefited the students or not, we shall set up a null hypothesis that special classes after school hours have not benefited the students. The null hypothesis can be thought of as the opposite of the guess the researcher made. Therefore, the null would be that there would be no difference among the groups of students. Specifically, in more statistical language, the null for an ANOVA is that the means are the same. Why do we do this? Why not simply test the working hypothesis directly? The answer lies in the Popperian principle of falsification. Karl Popper, a philosopher, discovered that we cannot conclusively confirm a hypothesis, but we can conclusively negate one. Therefore, we set up a null hypothesis that is effectively the opposite of the working hypothesis. The hope is that, based on the strength of that data, we will be able to negate or reject the null hypothesis and accept an alternative hypothesis. In other words, we usually see the working hypothesis in HA. Step 2. State the alternative hypothesis. Alternative hypothesis, any hypothesis which is complementary to the null hypothesis, is called an alternative hypothesis, usually denoted by H1 or H alpha. For example, if we want to test the null hypothesis that the population has a specified mean, then we state the alternative hypothesis as H1 is equal to mu not equal to mu 0. The alternative hypothesis in 1 is known as a two-tailed alternative, and alternative in the second instance is known as the right-tailed, and the third one is known as left-tailed alternative respectively. The setting of alternative hypothesis is very important since it enables us to decide whether we have to use a single-tailed right or left or two-tailed test. Step 3. Set alpha, level of significance, and critical value. Level of significance. In testing a given hypothesis, the maximum probability with which we should be willing to take risk is called level of significance of the test. This probability, often denoted by alpha, is generally specified before the samples are drawn. The level of significance usually employed in testing of significance are 0.05 or 5% level of significance is chosen in deriving a test of hypothesis. This means that there are about 5 chances in 100 that we should reject the hypothesis when it should be accepted. We are about 95% confident that we made the right decision. In such cases, we say that the hypothesis has been rejected at 5% level of significance, which means that we would be wrong with probability of 0.05. The following diagram illustrates the region in which we could accept or reject the null hypothesis when it is being tested at 5% level of significance and a two-tailed test is employed. If we look at what can happen in a hypothesis test, we can construct the following contingency table. We take into consideration in reality what happens and the decisions that we take. Either we accept a null hypothesis when it is true, or we reject the null hypothesis when it is or we reject a null hypothesis and make a type 1 error. The other probability is that when the null hypothesis is false and we accept it, we make a type 2 error, and when we reject it, it is okay. It is important to note that we want to set alpha before the experiment a priori because the type 1 error is the more grievous error to make. The typical value of alpha is 0.05, establishing a 95% confidence level. Step 4 is the collection of data. Remember the importance of recognizing whether data is collected through an experimental design or observation. The next step is to calculate a test statistics. Collect and summarize the data so that a test statistic can be calculated. A test statistics is a summary of the data that measures the difference between what is seen in the data and what should be expected in the null hypothesis were true. It is typically standardized so that a p-value can be obtained from a reference distribution like the normal curve. Step 6. Interpret p-value. Interpret what the p-value is telling you and make a decision using the p-value. Does the null hypothesis provide a reasonable explanation of the data or not? If not, it is statistically significant and we have evidence favoring the alternative hypothesis. State a conclusion in terms of the problem. There are certain common decision rules that have to be followed, shown on the table at the 0.05 level. Therefore, p is equal to less than 0.05. For example, if t is equal to minus 2.40 and df is equal to 17, the obtained value of 2.40 exceeds the cutoff of 2.11. In a research report or journal article, the result is shown as t within brackets 17 is equal to minus 2.40, p less than 0.05. A plus or minus sign at the end associated with the t ratio indicate the direction of the difference between the mean. Group B had a better mean than Group A. The last step is based on step 5 and 6 and it draws the conclusion about the null hypothesis. Modern statistical software condenses step 6 and 7 by providing a p-value. The p-value here is the probability of getting a f calculated even greater than what you observe. If by chance the f calculated is equal to f alpha and the p-value should exactly be equal to alpha. With larger f calculated values, we move further into the rejection region and the p-value becomes less than alpha. So the decision rule is as follows. If the p-value obtained from the ANOVA is less than alpha, then reject the null hypothesis and accept the alternative hypothesis. So to conclude, we can quickly look at the steps in the hypothesis testing by looking at one example. This example appeared in the November 2014 article, "Do Not Drink from the Blue Mug" in the journal Flavor. Researchers investigated whether the aroma of a cup of coffee might be affected by the color of the mug they drink it from. In the experiment, 12 people were randomly selected to drink their coffee from a blue mug and 12 randomly selected to drink from a white mug. The research question is, does the color of a mug affect the perceived aroma of the coffee inside the mug? The explanatory variable, color of the mug, blue or white. The response variable, subjective rating of aroma on 100-point scale. Step 1 and 2, state the null hypothesis and alternative hypothesis. Step 3, set the level of significance and critical value as alpha and 5%. Step 4 and 5, collect and summarize the data so that a test statistics can be calculated. Step 6, use the test statistics to find the p-value. And finally, step 7, interpret and make a decision using the p-value. Since the p-value is less than 5%, the result might be considered significant. The null hypothesis provides a poor explanation of the data. Therefore, the null hypothesis is rejected. We have some evidence that there is an association between the color of the mug and the perceived aroma of the coffee. Well, friends, I am sure I have told you several times on these steps. So now you can work out your own hypothesis and start to test your research work.